Hi students, today we are going to discuss about the electric field intensity due to continuous charge distribution body. Last class we already discussed about the electric field intensity due to point charge. Due to point charge we already used the formula kq by r square. Electric field intensity at P point due to point charge kq by r square. By help of this formula, we find the electric field intensity due to a point charge. But now we are going to discuss about the continuous charge distribution body. How can you find the electric field intensity? How can you find the electric field intensity due to electric field continuous charge distribution body? So let us now discuss here. How can you find the electric field intensity due to a continuous charge distribution body? So let's know here. So first of all, we take one of the rod is here. So take a long L length of the rod. L length of the rod is here. Length L is there. This is total discharge is continuous charge distribution in this rod. Completely charge distribution. L length of the rod. By help of the continuous charge distribution body, this is a continuous charge distribution body. How can you find the electric field intensity at one point along this rod? Along this axis. Along this rod axis. Okay, so let's come here. At A, define the electric field intensity at this P point on this rod. But this is a charge distribution. How can you find this? So, for example, from this one end of this rod, at A distance, we can take this P point. So here, electric field. We find the electric field at this point at P point. The distance between the P point and one of the rod distance is A. One end of the rod and P point distance A. But this is total charge distribution. But how can you find this here? First of all, we take here this. Very small elemental charge. We take a very small elemental charge in this body. For example, here we take this very small elemental charge. Very small elemental charge dq. We take the small elemental charge dq, and distance what is the dx. This elemental charge and p point distance what is that here x. Okay, students. So due to this elemental charge, electric field at P point is radial. This is a positive charge. Yes or no? This total charge distribution here the positive. That's why due to this positive elemental charge, electric field intensity at P point radially outward. Assumption this is a dE outwards. Okay, students. Right. How can you find the total? This is only due to this point charge. Electric field intensity at this point, assumption dE is here. But our question is there. How can you find the electric field intensity at this P point total body? Charge distribution body. Okay, sorry. Right now here, first of all we find the electric field intensity due to this point charge at this point dE is equal to K dq by what is the distance between this point charge to the P point? X is here, that's why x is square. It's very important. So dE is equal to k dq by x square. Okay, students. But we know here this is due to this elemental charge. Due to elemental charge. Very small charge. Due to very small charge. That means elemental charge is any very small charge. Due to very small charge electric field intensity at P point dE is equal to k dq by x square. But we find is here what is that due to this total charge. Then we do what is that integration process we follow here. So just now here we define the total E net, total electric field intensity, total due to this total distribution charge. By help of this total distribution charge electric field find at this P point. So E net is equal to, when you do this integration dE, integration of dE is equal to, this is also the integration k dq by x square. Then E net is equal, how can you write? E net is equal to integration from which point to which point? One end is distance, from this point to one end, what is the distance is here? A. Another end of this rod, what is the distance from this P point? A plus length of the rod L. So A plus L. A plus, this is a integration point, limits from A to A plus. So next k dq by x. Okay, students. So let's know here k is a constant removed from this integration. E net is equal to k is a constant. So integration of a plus l dq by x square. But if we observe carefully here, linear charge density lambda is equal to charge per unit length. Charge per unit length. This is linear charge density formula lambda is equal, linear charge density formula lambda is equal to charge per unit length. Then you write the charge dq, unit length dx is here. Then you write lambda is equal to charge dq by dx. From this formula we find the dq. Therefore dq is equal to lambda by dx. Yes, sir. This dq's value is substitute. This dq value is substitute here. Then you get what is that? E net is equal to, how can I write here? E net. Net electric field intensity E net is equal to, how can I write this here? So right now here, so this is a lambda dq here. Right now in this condition, lambda is equal to charge per unit length. Okay, students. Then lambda is equal to, what is it? Charge dq by dx. Then you find that dq is meaning lambda dx. Okay. This dq lambda dq is equal to lambda dx. This value substitute in this equation. So this is it. Raise it here. There is it. And then you find E net is equal to, how can you find it? E net is equal to, next, E net is equal to, k is a constant, integration, limit, what is the limit? A plus L, and dq, what is the dq? We already find lambda dx is there. Lambda dx by x square. Okay, students. Clear? And next, E net is equal to k, lambda also is a constant removed from this integration. Lambda, integration of a plus L, 1 by x square dx. What is the integration value of 1 by x square dx is equal to minus 1 by x. Okay, students. The E net is equal to k lambda, integration of 1 by x square dx is equal to minus 1 by x. What is the limits given here? A plus L. A plus L. Right now here, so E net is equal to k lambda. Okay, upper limit instead of x, upper limit minus lower limit. Upper limit what is it? A plus L. Lower limit what is it? A. So substitute here minus bracket minus 1 by upper limit a plus a minus of lower limit 1 by A. Okay, students? Okay. So upper limit minus lower limit. Right. E net is equal to, how can you write this? E net is equal to K lambda minus 1 by A plus L. Okay. Minus into minus plus 1 by A. So finally, how can you write this point here? E net is equal to total electric field intensity. Electric field intensity, total electric field intensity due to the charge distribution body. So E net is equal to K lambda 1 by A minus 1 by A plus A. Simply you write now here like that. So this is a electric field intensity due to a charge distribution body. Charge distribution body, electric field intensity K lambda 1 by A minus 1 by A plus A. Okay, students, right? Clear? Okay, this is such point is here. This is the L length of the rod we take here. If we take a wire, semicircular wire. Semicircular wire is a charge, continuously charged distribution in a semicircular wire. But how can you find the electric field intensity at O point? So let us know, we are going to discuss this point. So these concepts also is here.